In the previous episode, we discussed some unsolved mysteries that scientists are currently researching. Today, we continue with that topic and talk about some other things that scientists have been researching for many years. One very interesting phenomenon that scientists are aware of is antimatter. For example, everything around us that we can observe and touch is matter. Now, scientists have said that when we started studying everything in detail, we realized that everything has its own pair. If there is a particle, there is another particle paired with it. So, scientists observed that if there is matter, then there should also be antimatter. And indeed, their research proved that antimatter can exist. Not only did they prove it, but experiments have actually shown that when you mix matter and antimatter, they annihilate each other and release energy. Now, you can think of this concept as similar to how we think of +1 and -1. When they come together, they become 0. In the same way, you can think of matter as +1 and antimatter as -1. A major problem that scientists faced was, why is there so much matter in our universe, but we never see antimatter? We've never observed anything that suddenly disappears, or that comes into contact with antimatter and explodes or vanishes. Another big problem scientists faced was that when the universe was created, why was there more matter and less antimatter? If the universe had formed and the quantities of matter and antimatter had been equal, they would have annihilated each other, and the universe would have ended as soon as it began. This is a natural phenomenon that scientists still don't understand. Why did this happen? If the universe is so symmetrical and follows every scientific rule, then why is there so much asymmetry here? Why is there so little antimatter and so much matter? Who did this fine-tuning? Scientists have been researching this for a long time, and as of now, their opinion is that we don't know, and research on this can only continue. In some of the previous episodes, we explored certain forces, the force of gravity, the force of electromagnetism. So in our universe, there are 4 fundamental forces. There are no forces beyond these. We can feel gravity, we can observe the electromagnetic force and the strong nuclear force. In our observable universe, there is no other force, and these are the 4 forces that govern everything. In our observable universe, we know about gravity. Anything with more mass has more gravity. We also have an idea about things like friction and so on. The strong nuclear force is the force that holds protons and electrons together, and then there is another force called the weak nuclear force, which is also a very fundamental force of nature. In fact, this was discovered by a Pakistani physicist, Dr. Abdus Salam, for which he was awarded the Nobel Prize. So these are the 4 forces. Establishing a relationship between them is a very difficult thing. Not only is it difficult, but if such a relationship is established between them, we encounter a phenomenon known as the theory of everything. As we discussed before, when we talked about quantum mechanics, that was a completely different branch of physics. And when we talked about galaxies, that was an entirely different field. The things we observe at small scales are not visible at larger scales. What will explain this? Is there a theory that can connect them? The theory that connects them is called the theory of everything. And scientists are researching this theory of everything, trying to find a formula that can explain every aspect of the universe, a single formula that contains all the variables, so that if we use it, we can relate every phenomenon in the universe. Just like E equals mc squared unified the entire field of relativity, such small formulas can have huge implications. So, is there a formula that can relate every phenomenon in our universe? Such a formula should exist, because this is the foundation of science, that everything has some underlying effect or cause. Similarly, the concept of parallel universes is also a very interesting phenomenon. We discovered that some scientists say there is nothing inside black holes, and the concept of parallel universes is such that you can solve many problems if you consider parallel universes. Some scientists say that the mass of black holes only makes sense if you consider parallel universes. You could say that it links you to another universe, and a parallel universe is just like our universe, a mirror image, you could say, where the same activities are happening as here, just with slight differences. And it's not just one universe, there are many universes embedded within each other. This concept is very strange and bizarre because we have no evidence for it, nor do we. This is one way you can solve these equations. You may have noticed that to solve these equations, scientists have come up with very strange and unusual ideas. If an equation can't be solved, they create a parallel universe, and then the math works out and the solution is found. One very terrifying phenomenon that scientists research is how the universe will end. Although this isn't the most important research, scientists have still studied it to make some estimates about how our universe began. It's been 14 billion years since then, and we don't know how much longer this will continue, or when the time will come that the universe will end and what will happen when the universe ends. But usually, we see that if something is created, it also comes to an end. Everything in the universe has an age, a star is formed, and after ending it becomes a black hole. Galaxies are formed and later become elliptical. So everything is such that it comes into existence and after some time ceases to exist. So scientists said that since our universe has come into existence at some point, our universe will also come to an end. So, when scientific research meticulously investigated this, they extensively studied the continuous expansion of the entire universe and subsequently described 3 distinct scenarios that could comprehensively explain how our universe will ultimately come to an end. The first scenario is the Big Freeze. You probably know what heat is. If there is heat in a place, it means that the air there is vibrating very rapidly. Its molecules and atoms are vibrating at a very high frequency. That vibration frequency determines what the temperature of that area will be. So when the universe is expanding, all the material inside it starts moving farther and farther apart from everything else. And when things move far apart from each other, there's no longer chaos. Everything starts becoming very systematic. Because of this systematic arrangement, the temperature drops and it gets colder and colder and colder. So, according to science, there is a point at which the temperature cannot go any lower, and this is called absolute zero, minus 273 degrees Celsius, below which the temperature cannot drop. So scientists say that during this expansion, a time will come when the temperature of our universe will reach minus 273 degrees, and when it gets to this temperature, our universe will freeze and be destroyed. The name of the second phenomenon is the Big Rip. The Big Rip theory says that as our universe keeps expanding, it will expand so much that the very fabric of space-time, which we explored in gravity, will start to tear apart. That fabric will rip, and the expansion will continue to such an extent that it will tear everything apart. As things get torn and ripped, they will be destroyed, and eventually nothing will remain in the universe. So, there's the Big Freeze and Big Rip. Scientists lack much evidence for these scenarios, as we've made quite a few assumptions. But the last one, which is called the Big Crunch, scientists actually have evidence for this, and it's quite terrifying, because scientists have understood gravity, they've understood the beginning of the universe, so they realize that the ending will be quite symmetrical. They realize that as our universe keeps expanding, the gravity within it will become so strong, with so many stars and planets, that it will start pulling back on this expansion. There will be so much mass inside our universe. Just like the Earth pulls on the moon, everything in the universe will start pulling on that boundary. Because of this, the expansion will stop, and not only will it stop expanding, but it will actually start contracting again. And it will be something like the opposite of the Big Bang. Just as the universe began, the opposite process will start to happen. All the planets will come closer together, all the stars, all the black holes, all the quasars, and even all those things we haven't even seen yet. They will start to collide with each other, begin to merge. The temperature will become extremely high, and as everything contracts and comes back together, it will shrink down to absolutely zero size. So these concepts were quite terrifying, but there's no need to panic, because even if something like this does happen, at least we can be happy that we explored all the beauty in this universe. In a way, it was a blessing for us that we got the chance to explore all of it. I mean, look at quasars, look at galaxies, look at stars. If we hadn't had these things, and if we had lived in a time when we didn't have this much technology, we would never have been able to appreciate them. So there's no reason to be sad that all these things will come to an end. The joyful thing is that you explored and experienced these things, and that's the essence of science. That we never make meaningful statements about what will happen after the universe, or what existed before the universe. We will simply try to understand what exists and enjoy it. My name is Hassan Ahmed. Thank you very much.